Okay, today's date is the 22nd of January 2026. The time now is 7:24. Okay, question PhD, I run a constitution. So let's get started. So it's not negotiable for me to do this properly. I don't run an empire yet. I don't run an because it could be like if I say because I do like the empire model, but I don't like the kind of fragmentation. So it's constitutional run. So maybe okay, today's video is on this map I've got here. Very informally, I've got this written down. Whatever. Electrolysis polar nodes now I wrote refinery, electrolysis and pyrolysis. So if you don't understand these terms, you are not really understand what it is. What I'm going to do here. So electrolysis is so electricity is the the electrodes, work on the electrodes again. So electrodes are like just wires, physical wires that electricity goes through. Electrolysis works on waves, propagates as waves. So it's basically about propagation, but electricity is basically wireless power. So yeah, so we are going to have wireless electricity power. So no, good pyrolysis, petroleum, pyrolysis. So you got pyrolysis, which is like a few. I don't even know if I remember correctly, but you got a few. I'm gonna try to remember it. Pyroreactor. Because you got pyrolysis. So pyrolysis basically works on fuel like fossil fuels. So things you get from natural air. So this brings to my question: why am I talking about fossil fuels and electrolysis and pyrolysis? Yeah, the thing about pyrolysis is they are fossil fuels, so they are things that we actually use for cars, transport. But they're just for those kind of things. That's why the fossil fuels are only needed. You don't need to use something. You can have them separated, but it's no good to separate them because you can have an electric car. It's just a different medium. You charge. So the goal of this is to have the two joint in transport as foundational resources when you have it in your house. Something like that. So you can separate. You can have you can charge your car. You use the power to charge your car and the power to charge your car to use the fuel. But you can't separate them because just separate them in the tanks, of course. But you have to take something to go. If you got electric, imagine an electric guild. Electric guild that gives you power. Electric guild that gives you power. That's what I want you guys to have. Something that charges you. So you usually have to use the fuel to get them. And if you don't have, if you can't log in, just connect to the electric grid and charge your car. But you don't have a fixed space for it. Because you're gonna have something. So you're gonna have a charging station, but the charging station is gonna use the electric grid around you. So you basically have a place you can park. So when you're parking your car, you're charging it in a business room electricity. So that's a go. You have somewhere you can charge your car, but that charge car can be powered, wired, and wireless. So you just need the electric grid to be there. So electric magnetic field to charge your car, and those are the car parks. More you guys have. The kind of van packs. You're gonna have you're gonna have guys when you're driving. You're gonna have a charging station. Well, that charging station is gonna be electric and electronic. Only for now, this was your car parking them, but you're gonna have some kind of a fuel system there as well. But don't get into fuel. But you're gonna have electronics, electric charging car in your car park. So that proves to me is sustainable. Now you don't go to a charging station. There's no charging station for the car. You just go to a car park and you charge your car. Anyone that's normal country has to pay for the charging car. So, it's sustainable to use it. It's basically utopian building. But I'm building for one dystopia. So because the thing about going for transport, going from point A to point B, is you charge your car. So when you get to this point B, you're charging your car because electricity allows you to do that. And you got pyrolysis, which is the refinery of the crude oil system. But the pyrolysis is basically one to travel for the airport for the stuff. So I want to use pyrolysis for longer distance. Because so if you have something to charge, if you go from point A to point B, let's say how does that go? From Lagos to Abuja, or from Abuja to Nnewi, or Onitsha, which is my friend's place. I want you guys to just have that long distance travel. Only cars. Only cars with a paralysis, because that means the fuel enough is good enough for you to go from point A to point B, and back. And that's the goal, not just one way. So it seems like a long distance to say, but that's the very first. You used to go from Lagos to all the way from Lagos, which is Oma, or which is Otan, from Abuja to Nairobi, and that's what you used to do for the president. But, that's what the fuels are meant to do. Fuels are meant to get you from point A. So if you can't do that, constitution, you can just charge your car, charge your car with electrolysis. So with electrolysis, but you can also put so as a policy, I'm making sure that you have power when you need power. So this man, when you're in your car, you're singing or dancing, you're literally just not worried about power. You're not worried about power. So you're gonna have the meter. Go show the meter of electricity you have. And you're gonna have solar panels. Solar panels. So you're gonna have something that's gonna charge your car. Keep so you're gonna have solar powered. But you're gonna have that so the connected energy. So that solar power will be go because Nigeria is Africa. So you're gonna have solar power. You're gonna have three things. Three things. You're gonna have solar powered vehicles. Literally just by design, there's no explicit sort like it's gonna be natural. So you're gonna take in as much energy as possible into the power bank, of it. And you're gonna have to swap that power bank out. So you can swap that, you can store it, and you can turn it off. So you can remove the power bank. You have two power banks for every electric car, for solar power car, and then you have solar power car, and you're gonna have a charging stock station that is that is electro bound. So in case of the old cars, so for the old cars, these are not solar powered. You're gonna have like a charger for the charging car, but use electricity and fuels, fossil fuels. I'm proud to say it, but I don't think I can do it. But fossil fuels, and because that's a car park, and that's what socializing. You're gonna have a lot of cars there. It's not a standard car park. It's not like so you're gonna have the fuel for the thing you need. But you're gonna have it. Um, in some kind of a system of safety, so children can run it's not gonna blow up, and you're gonna have it go on the ground so you can see where it's. So basically, good of this is gonna have it on the ground because I don't want people launching missiles on it, and blowing up. So it has to be on the ground. So you're gonna have and also, and so you're gonna have the car park, which is like electricity. If you wanted, you have to go twice 30 meters on the ground to get the fossil fuel, the kind of pyrolysis fuel, which is the fossil fuels. I'm calling fossil fuels because they work on fossil. So you can have just like 30 meters, 30 to 45 meters on the ground to get fossil fuels, and on the surface you can get all the electricity fuel. Basically, park, you have to go on the ground. So it's a car park, but it's on the ground. So just remember that it's a car park. You can eat there, you can dine there, but it's basically on the ground system for charging cars. So anybody that charge your cars to go up, it's not even a social place. You just park your car there, and you say you basically it's basically a well. It's a well. So it's a well model. Basically, the well model is basically the model of organization. Everything's in wells, and wells are dug. So the more you dig, the more energy you get. So you have to go on the ground to get the energy. So you have let's say you have 30 meters to 30 15 30 30 45 60 meters 60 meters on the ground, and then 60 meters on the ground, and then you have 30 meters on the ground of fossil fuels for the cars and for the logical. You get 60 to 60 for this plus 30 is 60 70 80 90 60 to 90 meters on the ground for lorries and stuff like that, because lorries it's not private, but for basically the separation question of the vehicle. So you cannot take a vehicle as a car and go on the ground twice. You cannot go to the system, because, those are for the lorries, the vans, people that actually want stability and want to have it. But the goal is to have the fuels be on the ground because they come from the earth. They don't come from the surface. They come from the earth. It's more natural. It's more sustainable. So it's basically meant to work on the kind of the infrastructure. Because, you can then stop. Because, you're gonna work before we get trains or something like that. Because you're gonna have trams. You're gonna have a cargo bay. But no one should be taking your cargo. No one should taking your stuff. So I want to make sure that it's safe for you to have some kind of transit up underground and up. But there's no elevator. No. It's a well model, but you have to walk. You can walk on the ground. You can walk on the ground. You can take the elevator facility. You can normally to get you can go to you just go to where you need to get your car, lorry, and you can go back up again. And you get the last one. So the last one is basically the refinery. So you get as so you get 30 to 60, 60 to 70, 80, 90, and 90 meters on the ground plus another 30. 90 plus 30 is 120. 9, 10, 11, 12. 120 meters. So 120 meters is basically where everyone goes, it's basically, I don't get you going there, but you going to refine the oil, but it's basically the way you get it to, but, that's basically 90 to 120 meters. You can see, anyone has a problem, anyone that works there in that setting can go on the ground, but they can go to refine it. But that's because the team, that's the teamwork. So I'm trying to stop the noise pollution. The noise pollution, and it's got a problem. It's on the ground, so you stay on the ground. You can refine on the ground. You can work on the ground because it's a mine. So this is where the mines are belong to. The mine starts from 90 to 120. So it's accessible. So you don't want anybody dying. So that's it. But so 120. And this is mine one. This is a mine one, mine A, and you get mine B. Mine B is like okay, this is mine B. This is mine A. This is mine B. This is like this, and mine A is looking 120 to plus 30, 150 meters on the ground. But that's like the system I'm building, so you can get some for energy. So energy is the surface. So it's basically anyone that's there. So there's no point. There's no noise pollution. There's no oil pollution, and and you got living quarters there. You got living quarters at the mine. So because you if you charge your car, you need to go in up, going up. But I want to so I want to make sure that some space. You see, you have to. So I'm gonna add some padding for the system because it's not sustainable without some padding. So the padding will be let's say 15 minutes of land. 15 meters of earth that no one should disturb. Because it doesn't matter whether there's a sound or not, it shouldn't disappear to the surface. It shouldn't disappear. So so you're gonna have a 15 minutes padding. So 15 minutes padding for each land. But, it's gonna be like the padding is gonna be man-made. So it's gonna be natural. It's gonna be natural. It's gonna be man-made because it's a padding. It's gonna be like a still soften the sound. All before you cannot hear the thing. It just disappears. Like some sort of cutting. So that's the goal. Because I don't want anyone telling me what to do anymore. So that's what matters. So on to the next topic. So we got the model here. So again, it's 30 to 60 meters for the cars, 60 to 90 meters for the lorries, anyone 90 to 120 meters for the airplanes, kerosene. But kerosene, no kerosene and stuff like that. And you get your mine A and mine B, which is 120 plus 150, and 150 to 160, 170, 180. 180 just for safety. If this works, you can go. If this works properly, we can go deeper. But I have to make sure it's safe. To look at the meters of land. Because it's a well model. So I don't want people falling in the well and dying. I just want people to just get the oil and go up. Get what they need because it's just for project of the world. So you can go see the problem, but there's no explicit like in my country, there's no, because it causes a lot of noise, and I don't like the noise. You have to go where the earth oil is, and the other thing I want to enforce is like the because you got tectonic shift, so because you have to follow the oil. So you don't just make this kind of refinery anyhow you want. You gotta have have a reason to make it. So you have to have it on the ground, but you're gonna have it as a place where there's oil is gonna go. So you gotta follow where the oil is. So because the earth moves, you got tectonic shift, which doesn't affect land, but you got because I love Nigeria, Biafra, so I'm saying I'm Biafra. You got land, so it doesn't affect the tectonics of the place movement unless because remember you got the oil where the oil is, so you have to go where the oil moves, and that's the science of the thing. So the next steps for this, so basically I don't like following oil, so I'm saying you have to go where the oil is because that's a very that's where you're gonna plant the refineries, and the refineries are on the ground. They're meters on the ground. They're like 120 meters, 120 meters on the ground. So the goal of this was safety. Of course, because it came from the earth station. This electropyrolysis and electropyrolysis in action. So you can take. I'm trying to have a polymer conversion that converts polymers such as propane gas, which is like a fire hydrant, things that can do them through elemental systems into because they will into distill them into distillation into electro so you can convert that, but that's a big one to do. but you have to use fission and fusion. So you can have nuclear reactors there, reactors, but the reactors are not safe. So I'm trying to do that myself, but for now, so you know. So again, one thing to do is use measure I'm to take the technology shift of the plate and measure where the oil is gonna go in the next 100 years or so. But every 25 years, we have to find new location for them. But we have to just have that location as a fixed place. So it doesn't matter where the oil is moving. We're gonna have the way so we can know where to dig, where to plug oil. So it's basically following the oil, following the oil, based on our geology, where we are, geology, how the geography and good geology, which is how our how our ontological system does the moving of the plate. But we got a lot of oils and the crude oil, but you have to distill it into boiling point. So the boiling things on the ground, but you have to have a safety protocol. So you have to have so you basically it's an inverted triangle model. So you got a triangle like this. If I did it like this, it would be bad. But this is like everyone goes. This is a triangle, but the basis has to be very strong. So this base is basically where the people are gonna work. I'm gonna be doing my project, so I'm gonna be going up to the oil. So we guys gonna be seeing the oil pump out of the ground, but not like that. You're gonna have it in the kind of tanks that comes up, so it's gonna be safe. So you can know that the oil is actually being verified. So it's really a boiling point verification protocol I'm trying to have, based on whatever the oil was. So basically, you can not take it out of the ground if it's not pure enough, perfect enough. You just need to get what you need. We can take all of that, going yes, for like a sort of check. We don't have to put it back. But you got to have the purest mineral form of the oil, used for so it can be used for diesel and same cars or so it's basically a safe oil. So this is my second power. I said basically my power project is not complete, but the kind of thing I'm saying for power is I don't want to ever lose power to anyone. But it's basically you cannot have anything. You cannot have a hospital on the surface. Because someone can bomb it, so you have to have it on the ground. Because one comes from women. So it's based on ontology of stuff. You cannot have a tower. The tower that you can have some kind of. I'm going to lose the ground for safety. For safety, we go compound. So the compound triplex model should be like some kind of bubble quality system. So it respects the kind of bubble conscious bubble. But that's the goal. It's meant to be safe. So it's meant to be on the ground. On the ground, on the very positive. That's the goal there. So you got the technology shift of our geology, which are model how our Earth cosmos and kind of safety protocol around that. So it's basically a localized, decentralized power and fuel structure, power fuel system. Because the power is basically a fuse is basically turned off. So it's basically localized and decentralized. So we know how our Earth moves, and we can measure like we measure the weather. So it's basically measuring the weather. If you don't know what I'm saying, just think about the weather, how the rain, how we get water, and when it's basically inverted. It's basically weather but for the Earth. Because actually that makes sense to me. So it's basically that's the say. So if you don't know what I'm saying, that's the whole project I'm working on for the power system. But I'm gonna use people to get this kind of power I need to do this because that's the first step I think is really important for my compound complex. If in case anything, it's not about building a compound. It's about getting the power first via pyrolysis. And pyrolysis is very important for decentralized, meaning that there's no single point of entry that can be neglected. No single point of because I love Letitia, but there's a lot of power in Letitia that's been neglected. I don't like that because my friends were there. If I didn't have friends there, I wouldn't say this, but that's why I have to go. I'm going to Letitia because I love Letitia. Letitia has so many great stuff. Great people, but they're one of the poorest people that I've seen, even poorer than me, or even poorer than Enugu. And Enugu has compounds. Indonesia has compounds too, but I've never seen. So I don't believe that. So that's what I'm saying. I've even seen Indonesia and Indonesia has compounds. Yes, I know that Indonesia has compound, but I'm saying that I've never seen a compound in Indonesia unless I'll be so. But I'm being the world first complex. So the electricity generator and the propane thing, there's a propane bombs, things like that. It has to be managed safely. So it's not negotiable to have them on the ground. But you have to have them separated. So they have to be decentralized. So you cannot ruin the whole system of the whole infrastructure build. So you cannot just have a single point of entry. So you get it. So you get so this is a triangle. This is a triangle bit with a base, strong base, and this is an inverted triangle. So if this blows up, pops, this will start folding itself. This is start like so. See, look, I just folded my shoulder. This is just what the structure will be. So I'm trying to use the structure here to make it like since you see it's broken, it has no base. So I'm just make it have a base. So it's basically an inverted triangle model. So it's a base, it's a kind of a base, but it's basically people. It's like it's a complex. Let's call it. Let's say it's let's just for now. Let's just say it's a underground underground duplex. No, triplex. So we're gonna have an underground duplex. Because they don't want to, so we're gonna have an underground duplex for this kind of stability. Let me do underground triplex for power. So, but the people gonna work there, so it's a safety protocol. The people gonna work there. They have to live there and breathe there. So it's going on ground level is not really the point. Is basically to have some all the food, all the resources of all the plants. And you gotta have food, water, shelter there. Breathing is optional. Life is not optional because you're working. This is like a dude that give us food. So you're gonna have breathing and being alive there and living there, breathing alive and living in the underground compound. But the compound is two. Cause you have two compounds. You have a two duplex two duplex on the ground, which is a quadruplex. But you're gonna have them as as for points of access. So you're gonna have all of them separated as a peer-to-peer topology, as a bus ring topology. So it doesn't blow up everything, even if we make a mistake somewhere. Because I don't want to die making this kind of system. So it's basically meant to refine oil. The oil refines on the ground, but it's need to refine them safely, give them space, and make sure that it's not a hazard in any sense of the word. So that's all for today via the boiling points. Now about the boiling points. About the boiling points. Okay, this number. About the boiling point. The boiling point is not. Yes, you guys should do the boiling points. So you get a boiling point here now. One, two, three. So the bullet points are again important because so you got to like I'm trying to take the efficiency. I'm trying to get stability for energy. So it doesn't matter if it's a phone or not. If my phone uses electrolysis, I want to turn it on and still have electrolysis left. It's just kind of problem of polymer bonding bonding and breaking via unstructured. You can have unstructured unsaturated information, unstructured facts. These that chemical how to break. Which are called unsaturated, they take more energy, but you can have things that are saturated, which takes less energy. But you have covalent bonds too. We can't remember what is called the covalent bond, but it's chemistry 101. Because let me try to find out covalent bond and covalent enable. I need to so let me find something. So a covalent bond, So you get an ionic bond, and you get a covalent bond. So ionic bonds are covalent to two chemical bond. The chemical bond is two or more atoms of ions. Ionic bonding. So ions are basically ions are the ions. What are ions? I don't even know what ions are. The meaning of ion bond is how quickly how equally the electrons are shared between atoms in the bond. So here are the description. We have to prioritize one. Basically the kind of saturated system of covalent bonding are the system of polymers trying to invent to distill two into electrolytic composition. So we see energy to power ratio. Power to energy system. Ionic bonds are metal and non-metal. They are non-metal attract to electrons, so it's like metal does need electron to donate its electron to it. Bonds are two mono, very similar to electronegative. Atoms share the outer orbit. So the share, this is covalent, but the share, but they like to donate. So the share, basically, they want to become stable. Electronegative, large electronegative particles, zero or small electronegative particles. Polarity is high. Polarity high, low. What's the shape? Non-defined shape, defined shape. Okay. But the kind of a chain of electrons is kind of interesting because that's how they bond, and they bond by the kind of energies the isotope is to isotope. So they have some isotopic conversion, which is a system of isotope resolution, which like kind of, you got isotope, which like kind of a sparse model of bonding, kind of many ways you can bond. So just look at the type of bond you can have, which is ionic bond. So the sodium sodium chloride NaCl sulfuric acid Fe2 methane SEM. So it's basically a system of structured so I'm gonna stop this video now and pop it to my YouTube. But let me see what I just read what I'm saying. But the goal is to have a system structured as via the oil room, so via the kind of boiling point. But the boiling points are on the ground. All on the ground is very velocity. Other policies are so you got things. So you can't steal from us. You cannot. I don't want people to steal from me. By me I mean like a person that made the oil. So so you got 650 gasoline, this blueprint 650 Fahrenheit gasoline, 450 to but you're going to have the boiling point less. The more you boil, the more you can get out. But the more the boil, the more something you need to, the more power you, so you get the more power you need to boil. So I'm trying to take the more power, so the more power you need to boil. So that I'm saying it's not efficient for me to keep boiling. So I'm trying to use gasoline and distill. So if I boil at 90, if I boil at gasoline at 250 degrees, which is the maximum gasoline can come, and then I boil at 450 to get diesel, 450 degree Fahrenheit. Because your body works in Fahrenheit. It doesn't work in Celsius. If you don't understand that, you know what I'm saying. So Fahrenheit is just basically a different one for your body. So all nurses on those use Fahrenheit, not Celsius before they use Celsius. The Celsius is just so Celsius is very bad to use. My body. If you're in the cold, I was cold. My body was 115 degrees Fahrenheit. I calculated my head with Fahrenheit. Minus 15 degrees Fahrenheit, I also calculated. So my body's on minus 15 degrees Fahrenheit. And that must mean that minus 15 degrees Fahrenheit is my body temperature. But that's basically 32 degrees Celsius, if I remember correctly. Minus 32 degrees Celsius. So let's just do this. So all those are profession to use Fahrenheit, process Fahrenheit first. Because that's why I used to do it with health. I'm gonna use minus 15 degrees Fahrenheit. I don't know. To Celsius. I don't know because when I was in danger, this will help me save my life. So it's basically a system of Fahrenheit to Celsius. So get to minus. I'm just minus. Okay. So basically, I was cold. So that was minus 26.111 Celsius. So I was cold. So basically, this is what I'm saying. So this is Fahrenheit. This is cold. This is what I'm saying. So Celsius is more accurate. If the room is warm, yes. Remember, if the room is warm, and Fahrenheit is zero, then you get minus 17 degrees Celsius. So it's not really good to do that. So it doesn't make any sense. So if you have 46 degrees Celsius, you have 7. But if you have Celsius first, Kelvins, Newtons. Newtons is power. So if you have if you have the 32 degrees Fahrenheit, you have 0 newtons. So basically, the Fahrenheit. I'm saying what I'm saying is because you get what I'm saying is you get 32 degrees Fahrenheit to newtons, which is the power, which is 32 degrees Fahrenheit, which is newtons. So 32 degrees Fahrenheit is 0 newtons, 0 newtons. So that's the power conversion ratio of force, of force. So newton measures of force, and because this is like Fahrenheit, this is like a temperature, the amount of temperature of entropy of Fahrenheit of how cold something can be. But I was minus 15 degrees Celsius for Fahrenheit. So my decision specifically, I need to be so I need the more entropy. So for me, I was cold when I was cold in when the police grabbed me and stuff like that on the 29th or before the 29th of 28th of January, 28th of December, 28th of December, 27th of December. 27th of December, yes, 27th of December, before on the 30th of the Grammy from here to this place. So minus 15 I was for minus 15 Fahrenheit, and that's minus 8.6167 newtons. So I'm just giving you a bit of computation so you guys can go along this OB next system. You know what I'm saying? So the minus 15 degrees Fahrenheit is 0 minus 0.6167 newtons, and 0 degrees Fahrenheit is 0 degrees Fahrenheit is minus 5.8667 newtons, and then 32 degrees Fahrenheit, which is not so Celsius, is 0 newtons. So the newtons represents the amount of force and what I was called, because things are dynamic. So I'm trying to map Fahrenheit to Celsius and Fahrenheit and Fahrenheit to newtons because newtons represents force, and that's what I'm saying. It's basically a system that respects your body because the newtons equals the power, the power of it. So it's basically a Fahrenheit in degrees, Fahrenheit in degrees, and you get I'm gonna do Celsius, which is Celsius. 100 Celsius is how many boiling point to Fahrenheit, which is 100 Celsius to Fahrenheit is 50 Fahrenheit. So 10 Celsius is 10 Celsius equals 50 Fahrenheit. 100 Celsius equals 2.1. So this is boiling point of water. 2.12 Fahrenheit. So basically, it's not really Fahrenheit is basically different for the system of we're gonna use Fahrenheit because it's stable. It's stable for us. So it's stable for the system. Thank you guys. So Fahrenheit is basically the default for kind of body. Because 100 isn't the full story what's gonna happen to your body. So 2.1. 2.212 Fahrenheit, 100 degrees Celsius, and that's boiling point of water. So if I put one more thing, let me put 400 degrees Celsius, 400, let me do 450 Celsius. This is 842 degrees Fahrenheit, which is not right. So I should be using Fahrenheit to Celsius. That'd be 450 degrees Fahrenheit, which would be 2.22 degrees Celsius. So it's half, but it's not stable. So maybe you should make it some microbes with Celsius and say, yeah, thank you guys for watching the video. I just showed you the Fahrenheit to Newton's calculation. You can use that to your work today. So it proves that I am actually working on something and it's open access, so it's not bureaucratic. Okay, but thank you guys anyway. Wish me the financial policy. Thank you guys. I'm making the variable policy now. So it's a for example open access. I'm not making this is very but I just showed you guys. So that's the variable policy. It will show you it can work. Even like this small bit, you can show you work in the video. Thank you guys.